Hey everyone, welcome to our very first video in kinematics. Today we're going to be talking about kinematic equations and how they're derived. First up, it's really important to just remind ourselves of all the really important physics terms that we're going to be using today. If you want more information on these, make sure to check out our previous videos called Physics as a Narrative, as Mathematics, and as Models, where we go way more into depth in these topics. First up, for just a quick overview, is reference frame, which is the point of view from which motion is measured. It is often just a abstract coordinate system, so that's like saying the x and the y axes. Time is measured in seconds, denoted by the letter t, and it is a scalar, so that's just because we can't actually have negative time. For position, this is the location relative to a reference frame. It's usually denoted by the letter x, and it is a scalar. So what's really important about this one is imagining the reference frame. So that's like saying 1, 0, which can be 1 meter to the right and 0 meters up. And that gives the viewer a really great sense of what the object is and where it's located. Distance is the total path of motion. It's denoted by the letter d most times, measured in meters, and it is a scalar. Displacement is the change in position or distance from start to end. It's denoted by delta x because if you look at position, it's denoted by an x, and displacement is the change in position. It's measured in meters, and it is a vector because you can go backwards, which signifies a negative. And now, speed, velocity, and acceleration. Speed is the total distance per unit time. It's often denoted by either an s or a v. It's measured in meters per second, and it is a scalar. This is because both variables in the equation, which are distance and time, are both scalars, and therefore speed must be a scalar as well. Velocity is the displacement per unit time. Velocity is practically always denoted by a letter v, but in order to maintain a difference between speed, in case speed is being denoted by a letter v as well, velocity will have a small arrow on the top, which is the symbol used to describe a vector. It's measured in meters per second as well, and of course it is a vector. And the key difference between speed and the velocity is one uses displacement and one uses distance. So if you run around a track at a constant speed, you will have a speed by the time that you end your race when you're back at your starting position. However, you will not technically have a velocity because you end at the exact same position that you start, so you have zero displacement. Acceleration is the change in velocity per unit time. It's usually denoted by letter A, and sometimes as well it will have the little arrow on top. And it's measured in meters per second squared, and it is a vector. So now we're going to delve into kinematic equations. And what's really key in understanding these is that these are only true when you have a constant acceleration. So when we deal with problems in AP Physics 1, a lot of times you have to split up a certain situation into distinct sections in which acceleration is constant, even though they're different in each segment. So first up, this equation, which is that the initial velocity equals final velocity minus acceleration times time. It is also sometimes denoted in the opposite way, that the final velocity is equal to the initial velocity plus acceleration times time. It is purely derived from the actual definition of acceleration, which is a equals the change of velocity by time. So actually there we have the other version of describing the formula, which is that the final velocity is equal to the initial velocity plus the acceleration times time. And now we're going to do our second one. It's just important to keep in mind the previous equation that we talked about. And in order to derive the second equation that we're going to talk about, we're going to have to think about the average velocity, which is just the final velocity plus the initial velocity divided by 2. Then we also have this equation, which is purely just the definition of x as a position, but we use the average velocity here, and then we can purely just substitute. And as we come down through the entire formula, we get this beautiful equation. which is that the final exposition equals the initial exposition plus the initial velocity times time plus half of the acceleration times time squared. Now for our very third equation, and now we're going to have to keep both of the previous equations in mind while we solve. So first we have this tiny equation, which is just derived from this equation, while the entire thing is divided by a, or acceleration. Then we can substitute into this equation, and as we derive it down through all that math, we get that 2a times the change in x equals the final velocity squared minus the initial velocity squared. Most times, including on your AP Physics 1 formula sheet, you will see the equation in this format just because it's easier to present. So that's all for us today. Make sure to put your comments down below, like and comment on this video, of course, and check out all of our awesome STEMmy videos here on our YouTube channel. Thank you so much, guys.